Everyone, hope you're doing well and welcome back to the All About session 2. So, a quick recap about the session that we did last time, where a user was sitting at home, opened a browser, Chrome, Edge, file, say, or any other browser using his Wi-Fi connection. So how the user will access? So first of all, what will happen? The user is trying to open this xyz.com and whose IP address is something, right? So the DNS resolution will happen. That is the first thing. As soon as the user will type in the browser www.xyz.com, so DNS resolution will happen. After that, IP address will be assigned, a route will be defined, and then it will be able to access. Okay, here we have not talked about HTTP and HTTPS. We are not talking about, okay? So the reason is that that's a wider subject and we do not want to involve. First of all, we want to understand the underlying infrastructure, that how a website is hosted, how the web works, how the internet works. So now we know there are multiple ISPs involved over here, right? 1, 2, 3, 4. One is the ISP who provides you the access, right? Like this router. This is the router which is provided you by your ISP. Okay, send it to back. Yeah, now it is better. This is the ISP. This is the ISP router, and this is your home router. Then this ISP can lease the connection from other ISPs, and it may decide from where your request will be routed. Okay, but ultimately you are not bothered. You're bothered just about this and the bandwidth that you will get. Okay, it is 100 Mbps, 200 Mbps, 1 Gbps, or whatever. So you should get that. Okay, now today's scenario, or say today's session, will be all about what happens in the data center. And before that, just to let you know what I have done over here, I have done smaller fonts. The reason is that we want to cover in a single slide a lot of things, right? Like the home, we have said that later on we will be putting the home firewall as well, and other things which can protect you from hacking. Okay, now we will see that today the data center. Okay, and we will also draw the whole office IT systems and how the office users like IT staff, admins, or sales will be connecting to the systems. Okay, and also we will cover the high availability part. So these are the things we discussed earlier, like ISP, router, proxy, gateway, DNS, DSCP, routing, firewall, website, browser, TCP, and UDP. What is TCP? Transmission Control Protocol. UDP, User Datagram Protocol. So TCP and the UDP, the basic difference is that this gets in TCP we get the acknowledgement, and in UDP we do not get the acknowledgement. It is a very simple, like you send one registered letter, or a courier which has got acknowledgement that the courier has been delivered, or you just send one courier and you don't bother whether it gets delivered or not. That's simple, right? And then today's topic will be mainly about the HA, load balancer, and the cluster. Let's see, okay, one by one. So we have to zoom into the data center now. Let's zoom into data center. So this is a data center. Till now, we could understand that we have got one router over there, and we have got the xyz.com hosted with this IP address. This router will have its own internal IP address as well. Okay, right? And definitely there will be so many other components. So let's see what are the other things which are involved in here. Okay, so there will be server. Yeah. Okay, so let's put a server over here. Yeah, or there could be a router as well. okay, where the links will be terminated. All right. So this, what will happen eventually is that this router will have one internal. So this is the data center LAN, I would say, right? Data center LAN. Okay. Let me just first of all delete this and let me draw it from scratch. I guess so that will be better for everyone. Okay. So this is so so there are VLANs. Okay, there are subnets which are there. We will talk about what is the VLAN or what is subnet. Okay, so we will define that also. But try to understand, there are areas in which we will have to put our infrastructure, right? To protect the protect it from hacking or say external world. And that is a very common general practices that we will talk about. But to make sure that your infrastructure is more robust and not hackable, okay, so we can put some more components over here, right? We will talk about very less about the firewalls. Okay, so we have a perimeter network, which is the only network accessible, or say from where the user hits. Okay, it means that if I am a user, I never ever hit any other infrastructure component at all directly. I hit over here. Then what it does, it sends this request inside. Okay, and that sends the request to the inside, okay, to the server, isn't it? So over here your app servers will be there. All right. Okay, so what if I will put a app server over here? Okay, let me copy some things from the other slide which I had already created actually, right? There are so many things over here. Okay, some components that I will copy, like one nice server, one nice database. Okay, I will copy it from here and I will paste it there. So we will make it one by one. Okay, I have already covered this session for other people. So but over here I want to make it from scratch. So what do you call? Okay, that you put a server over there, very good server. Okay, so that is your application server. Okay, so what I said, according to that, it looks like that this server or say this CI or say this router directly connects to this. Okay, this is what it is as of now. Okay, we are going to modify it. Okay, so have patience. And what happens is that it is not only the application server, there are database servers as well, right? Okay, so there is a zone which is a database server zone. Okay, we put our databases in the database zone. Simple, right? Let me send it to back. Okay, so that it is in the front and I can align it better. Okay, and what happens is that this server will talk to this database to serve you the data. Simple. Okay, it looks simple, very straight, but logically true. Logically true. Technically, it is 100% wrong architecture. Okay, why? Because this does not contain the high availability components. Now we have to talk about high. When we say high availability, so high availability means that there should be more application servers, there will be more databases server. Why? If one is down, then another will take control. All right, so I will have to copy it. How to copy it? Just copy it. Yeah, and it will be having one IP address. Okay, this will be having another IP address, correct? So let's say, okay, now we are going to talk about another very important thing. So let me assign it a IP address. Let me zoom in a little bit more. Yep, that's better. So it was 11.11.3.4. Okay, so I will make sure that this 11.11.4.4. Okay, and this is going to be 11.11.4. Suppose 5. And if I'm going to have another server, then it will be it can have the IP address like 11.11.4.6. So I've got 3 servers in here. Okay, normally people show this as 2, but I'm showing it as 3. It is a good reason. I'll let you know why in some time. Yeah. Okay, first of all, the difference that you're looking at is that this is 11.11.11.3 and this is 11.11.4, correct? So why is that? Okay, now I tell you, I will take this thing out of here, okay, and I will explain. Okay, so this is 11.11.11.3.4, right? So if I say the number associated with here is 255 255.255.4. Okay, now you should understand one thing. Okay, this is the IP address is made of 4 bytes. Okay, 4 full bytes. Now you should know one basic thing, that how many values one byte can store. That is, one IP address can store from 0 to 255 to 56 values. Okay, right? So it means that 256 values, 256 values, 256 values, and 256 values. How many values can be stored in 4 bytes then? Millions or billions, right? The combination it will become. All right, simple mathematics that you can do offline. Okay, but my intention over here is to tell you over here is that, sorry, it was supposed to be 0, right? So this is the combination. Okay, this is called the IP address and this is called the subnet mask. Okay, and this exists on each and every device. Okay, so on my laptop the network name, or say not network number, is 192.168.0 and my laptop's address is 13. You got the point how it is made? Okay, and my gateway IP address is 192.168.0.1. So we are in the same network. My gateway IP address is 1 and my laptop IP address is 113. That is fine. How it is made? Okay, so the every IP address is associated with one subnet mask. That is the configuration of a network. Okay, that is the configuration of the network, each and every. Okay, now the question over here is that how many values we can use from there. Okay, so what I told you, that it can have how many values? 0 to 255, 256 values, right? Okay, you cannot use 0 and you cannot use 255. So how many values you can use? 1 to 254, right? So normally the network is configured, any network is configured like the either the 1 and the or the 254. There can be the gateway IP addresses. Okay, in my network what is happening is that 1 is the IP address of a gateway. One basic principle. Okay, if you want to get out of your network, either you need a gateway, either you need a proxy server, either you need a gateway, either you need a proxy server. We will learn about the proxy server sometime later. Okay, proxy server is not the necessity, but proxy server is used if you want something to be accessed via the mechanism which will record each and everything. Okay, it is not like that the gateway will not record everything, but their functions, their capabilities are little different. Okay, so over here right now we are just talking about the gateway. So over here, if you say that if this if the user is connecting in here, okay, so over here, apart from this device, there can be another device which may have the IP address associated like .1. It may or it may not have, or this .4 itself is the gateway. We can configure this. I can configure this. Okay. So where I will have to configure? I will have to configure on my DHCP server, or if there is no DHCP server, I will have to assign this value on each and every computer manually. But this is a must if you do not have any proxy server. Okay, and I will let you know that how without this configuration with the only proxy server you can access the internet. Okay, this is not a necessity. Proxy server is not a necessity, but if proxy server is not there, there should be one mechanism that you can go out of the network, like you get out of your home, right? There is a gate. You get out of your housing societies, you get out of your city, there is a way, right? So there is a road which goes and it connects to get out. Airports are there, gateways, right? So that's the use of this. So you have to remember two things. 255 to 55 to 55. This covers your network identification, and if this is a 0, okay, this covers your this entire thing covers your host IP address. Okay, host identification precisely. But it can be 255.255.255 dot say 120 or 10 or something, 100, the subnet mask. Then what will happen? That you will have to numerically understand. If somebody is going to write that, then those many bits. Okay, so if I say 1 1 1 1 1 1 1 1, so this becomes my value of 255. All right, so if I have to use only few, then I will have to write like this. Correct. And now what number it will become? I will have to put it over there. If I will put it over there, that number, it will mask that. That is why it is called subnet mask. That particular ones will be masked and will be considered as your network number. Understood? Okay. So that is the significance. So that also means that it is having its own gateway. This subnet is having its own gateway. This subnet is having its own gateway. This subnet is having its own gateway. And these all gateways are connected in a big device, which is having the capability so that all these gateways can talk to each other. Correct? And certainly it will have much bigger capacity. It means there are smaller switches, devices switches. Note this down. We will talk about what is the difference between a router and a switch and firewall. Okay, that is a separate topic. But right now, today we are concentrating on the high availability. Okay. Now the problem over here is that we have got 3 servers. So how this request will be passed in here? That's a good question, isn't it? So for that, we have the device called load balancer. Okay, load balancer. And we have to create one more VLAN presentation layer. Okay, and we will have to put this nice device that is called load balancer over here. Okay, so let me try to copy that picture from there, which is the load balancer picture from my other slide. Yeah. Oh, that is the router picture only. I did place. So let's do that. So let me zoom in there. So what will happen eventually? It will connect to this device. Okay, and this device will balance the load. As the name says, it will balance the load between all these servers depending on the availability. Okay, now over here comes the function of the load balancer. Functions of load balancer. What load balancer does is that it has the configuration so that it can detect the availability of the backend infrastructure or servers and check which server is available. Okay, and accordingly it can direct the request to that server. It has the capability. It has the capability of what? Detection and sending the request, forwarding the request. Plus, it has the capability of recording the session. It means that if a user is connected and it is transferring the data, okay, and it is interacting with one server, so it can retain that session and it can sense or say it can record that particular user was previously connected to that server. So it will again, if that user is sending that request, the request will go to the same server. What is the utilization of that? You can think of that if the file transfer has happened and that file was kept on that particular server, the user may want to connect and delete that file or access that file again. So it should connect to the same servers again, right? Illogical, but and this is a good example. Okay, right? So just for the understanding, later on we will explore that what are the things that has to be there while we are configuring the infrastructure. Okay, so let's draw some lines. Okay, what will happen that this will send and this will send the request to any of these. Okay, it can send the request to this and this and this. Okay, just consider that. But all these servers are connecting to the single database. Wrong. Again wrong. So there should be a clustered database. Okay. So what does it mean? That there may be multiple database servers as well. Okay. Now let's talk about one scenario. That one user is getting connected, 10 users are getting connected, 1000 users are getting connected, 10,000 users are getting connected. Is this infrastructure going to remain same? Capability and the capacity management comes into the picture. That how much time did one server took to process the request and send back the response to the user. So we have to understand that, and accordingly we will have to increase the number of servers over here and the database server over here. Okay, so these database servers are called as a cluster. Over here, this can also be a cluster also and the load balancer also. Okay. Now let's understand. Oh my God, we missed one thing. Here is only one load balancer, so that is the wrong thing. So we have to have two load balancers over here. Why? If one is failing, another should be ready. Accordingly, this will also have two routers. If one is failing, another one can take care. All right. So, but how the IP address assignment will be? So it will have one IP address, say 11.11.5.4, I can say, and the other will have 11.11.5.5, and then they both can share. Right now I'm saying the share word, but I will explain how. Dot 6. All right. So actually, this these routers will send the request on 11.6. Okay. Now there will be heartbeat in between these two, load balancers. Try to understand. If one is down, another will automatically assign this IP address to him. So one is active and another is passive. So what comes in picture? Active and passive words. Remember these. Always one device is active, another device is passive. That is called clustering. Okay. So these load balancers are clustered and these database servers are also clustered. So only one database server is working. It looks like. Let's talk about, okay? Let's talk about that when the millions of transactions are going on, is this going to be only one database server which will be handling all of the requests? Because over here what we have done, that this load balancer will check that it is occupied 10%, it is occupied 50%, this is occupied remaining 40%. Okay, so this will be sending the request to 10. It has load balance. But what is happening in the case of the database server? What is happening? All right. So there will be some mechanism for sure that these database servers are also handling the similar number of requests on each and every server. They are sharing. Okay. Point one. Point two. Let's give them the IP address. Otherwise, how they will talk? So that was 4, 5. I will make it 6.4 and 6.5, right? Okay. So this network ID is 11.11.6. This is 11.11.4, 11.11.5, 11.11.3. And certainly there is a firewall in between which I have not drawn. Okay, let me put a firewall icon over here. Okay, just for the sake that you do not understand, you should not understand that we do not have security in place, right? So Control V in here. Let's go. Yep. So this is firewall. This is firewall, and there is a firewall, and there can be a further firewall. All right, but let's not make it too complex. All right, looks good. Now there is one problem. Okay, if this server is down by any chance, what will happen to the data on this server? That data will be lost. So there is another solution that is called the storage solution. Correct. So there are two kind of storage solution. Okay. So this is the application storage. All right. I'll put this icon only as of now because this is app storage and it has got many disks in here. Okay. Okay. Terabytes or petabytes of storage. All right. And you see it is associated with these application servers and it can be in the same VLAN or the different VLAN, or it can, if it is a NAS based, okay, if it is a SAN based, what is the difference between the NAS and the SAN? SAN, S-A-N, SAN, that is storage area network. Okay, NAS, network access storage. We will talk about this later on. Okay,
So we have to give the application storage to the application server, okay, where these servers will be storing over here, and there will be RAID applied. What? RAID. Let's talk about this when we will talk about the storages. Okay, storage and the backup solutions. Okay, right now we are just learning about the network. Okay, so let me just copy and paste it. Copy and paste. Okay. Oh, so little bit design, and this is my base storage. Okay, all right, and let me put the disks over here. Control V, smaller disk. All right, yeah, yeah, it's good. Yeah. So it can be any of the size, right? It can be extendable to something. We will see how the storage actually looks like in the data center later on, right? So these are associated with the database. Now, how does it look like? Okay, this is down, is still accessible. This is down, is still accessible. This is down, is still accessible. And this one server is down, is still accessible. If this entirely are down, these disks are down, say I take it out, is this still readable? Yes. Answer is yes. That is how the RAID architecture is. Okay, there are different kind of RAIDs. Okay, RAID 0, 1, 5, 6. So there are different kind of RAIDs, right? That RAID levels that we will talk about. But if any RAID is implemented, we have little bit of the surety of the getting the data back. Okay. Apart, then this is online solution. Okay. The offline solution is that we take the backup of the data. Okay. So that time our backup solution comes. Right now we are talking about the storage solution. So we will talk about the storage backup solutions later on. Okay, so this is how a data center looks like for a single application. If you have got multiple applications, what is going to happen? Obviously, it will be more tough. Okay, there will be more VLANs. There will be more firewalls. Am I right? Wrong. There will be limited firewall systems, but there may be more switches. We will talk about this, why I'm saying like that, okay, and how the devices looks like. Okay, we will see the devices practically, that how the devices will look like. So uh, let's see the high view before we close today's session. This is how complete, not I will say complete, but from the high level, how the data center looks like. Now office assistants or accountants are sitting over here. They will be connecting over here. How they will connect? They will use VPN or anything else. And but this guy is not bothered, isn't it? So that is how we have to design. We have to consider that what are the components should be there. We will also learn that to configure uh, uh, web server to host multiple websites on a single IP address, cluster it, load balance it, make sure it is highly available, and we will design each and everything. Yeah, we will see. So please subscribe to the channel for more updates, and please like it if you think that it is useful, and you are free to share this with anyone because these sessions are absolutely free. All right, like and subscribe. Thank you everyone. Bye bye.